Alright, this is momentum example number 5, and before we start this one we need to make sure we go through and talk a little bit about what the difference between an elastic, so here's the word elastic, and inelastic collision is. I'm going to go ahead and on this applet I'm going to choose elastic collision. I have a little car here which is blue. It's a wagon. It's not moving at all, and I have another wagon that is an initial speed of about 0.2 meters per second. You can see the mass of both of these cars is exactly the same, and we're going to do an elastic collision first. So I'm going to start this, and you'll notice that that first car comes in, and when it hits the second one it sends the second one on its way. Because they bounced off of each other, regardless of what their final speed is, because they bounced off of each other, they have an elastic collision. The second type of collision is called inelastic. In inelastic collisions, two objects will be going, one will be going towards the other one, and then they will couple together. They could both be going head to head and also couple together. That would also be inelastic. So the big difference between inelastic and elastic is in elastic collisions they bounce, in inelastic they come together. So for this problem you've got a couple of boys, and those two boys are in this first car. So there's our two boys, and they're smiling, and they're about to hit this poor girl here who, oh no, she's going to get hit, and she's not really sure what to do, but there we all are. They are moving in at an initial speed, and she has 0 initial speed. Let's give the cars some numbers. We're going to call this car number 1, and we're going to call this car number 2. The first thing they tell us in the problem is that the mass of the first car, well, first of all, we know it is a elastic collision. It's elastic because they're going to bounce off of each other. They also tell you that in the problem itself. The mass of the first car and the two boys together is 300 kilograms. They got that from 200 kilograms of the two boys, so that would be 200 kilograms. And then the cart itself is 100 kilograms, so when you add the two together you get 300 kilograms. They tell us that her mass and the car that she's in is a total of about 125 kilograms, so her mass is 25 kilograms and the car is still 100 kilograms. So when you add the two together you get that 125 kilograms. Next thing we need to look at is what is the speed of each car before the collision. So when we do these, we're going to say that anytime we deal with the first car, so there's our 1, we're going to put a 1 next to the item that we're looking at. And then if it's before the collision, we're going to use original, and if it's after, we're going to use final. So everything above the line, this would be before the collision, and everything below would be after. And so we usually use a little O to indicate before, means original, and then after or final, we're going to put an F in. Just look at it that way. That would probably be the easiest for you to do. Before the collision, her speed is a whopping 0 meters per second, so I already said that. We are going to say V2O. If you don't use these symbols, the problems are very difficult to do. After the collision, we see that the two boys now have a speed of 4.12 meters per second. We forgot to put the speed into our drawing here. This would be 10 meters per second. So notice that they slowed down, but they didn't totally stop like in the picture that we saw earlier. The final speed for the girl is something that we don't know, and that's what we're solving for. So we're looking to find out how fast is she pushed by the boys in that same direction. And notice that they're all going the same direction, so they all have the same sign. They're all positive as we go through. The next part of this problem is to plug everything into our equation. This is the equation that we use for any time we have a elastic collision. So that's one where two things will bounce off of each other. Notice that all of the things are independent here. There's nothing combined. When we plug all of our numbers in, we end up with 300 times 10, which 300 times 10 for the first car, 125 times 0 for the second car. And then this would be on the other side. These are our finals, or after the collision, 300 times 4.12, plus 125 times that speed that we're looking for. If I do a little bit of math, I'm just going to do some multiplication. I end up with 3,000 plus 0 is equal to, now we take the 300 times the 4.12, and we get the 1236 plus 125 V2F. Subtract 1,236 from each side, and I'll do that quickly here. 1,236, that gives me 1764 is equal to 125 times the final speed for the girl and the car. And if you divide both sides by 125, we find out that the final speed of the second car is about 14.1 meters per second. And that would be the end of the first problem. That's example number 5 in momentum.